The second way that the components or the resistors can be connected in is the parallel connection. If all the components or the resistors are connected across each other, forming exactly two sets of common points, this means they are connected in parallel. In this circuit, we have a voltage source that is supplying voltage V and current I to this circuit. In parallel connection, the voltage across the components that are connected in parallel will be exactly equal. So the voltage across R1 is equal to the voltage across R2 is equal to the voltage across R3, which is equal to V, the value of the supplied voltage. Now talking about the current in such connection, we know that the current is the flow of charge. What happens if this flow reached this point over here? Consider this flow as a flow of liquid, for example water. If an initial volume of water is flowing in this branch and reached this point over here, it will have two paths to continue through. The water will of course divide into two parts, a part that flows over here and the second that flows over here. So there is no way that the initial volume will exactly be equal to the volume that passes in this branch or the volume that passes in this branch. A part of the water will flow here and the second will flow here. So the sum of the water volume over here and the water volume over here will be equal to the initial volume. This is exactly what happens with current. The current will reach this point and a part of this current will continue to pass through R1 and we will call this I1. Then the remaining part will continue to pass over here until reaching this point, where a part will continue to pass through R2 and we will call this I2. The remaining part will continue to pass over here until reaching R3 and we will call this I3. So we can write that I is equal to I1 plus I2 plus I3, since I divided into I1, then I2, then I3. Applying Ohm's law over here, we can write that I is equal to the voltage divided by the resistance. Now before talking about this equation, let's talk about an equivalent resistor for R1 and R2 and R3. An equivalent resistor will have to have the same current that passes through these three resistors together when the same voltage is applied. So when voltage V is applied, the current that passes through these three resistors together cannot be equal, for example, I1, since I1 is the current that passes through R1, and cannot be I2, since I2 passes through R2 alone. Similarly, it cannot be I3, since I3 passes through R3 only. However, the current that passes through these three resistors together is the current that is equal to I1 and I2 and I3, and this is the current I. So for voltage V and current I, we will have R equivalent. So applying Ohm's law, I is equal to V over R equivalent. Now the current I1 is the current passing through R1. We said that the voltage across R1, since this is parallel connection, is equal to V. So I1 is equal to V, the voltage across R1, divided by the resistance R1. Similarly, I2 is equal to V over R2 and I3 is equal to V over R3. eliminating V from the numerator, we can write that 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And this is how we calculate an equivalent resistance for resistors connected in parallel. Now the general equation for n number of resistors is 1 over R equivalent is equal to 1 over R1 plus 1 over R2 until reaching 1 over Rn. When talking about resistors connected in parallel, we are talking about a current divider circuit where we can use the current division rule. Now suppose that we have this circuit over here where R1 and R2 are connected in parallel. The voltage source is supplying a voltage V and current I to this circuit. This current I divides into I1 passing through R1 and I2 passing through R2. We know by Ohm's law that I1, the current through R1, is equal to V, the voltage across R1, divided by R1, the resistance of the resistor R1. Similarly, I2 is equal to V over R2. The main current I is equal to I1 plus I2, which is equal to V over R1 plus V over R2. Taking V in common, I is equal to V into 1 over R1 plus 1 over R2. Remember that the equation for an equivalent resistor in parallel connection is 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3 until reaching 1 over Rn for n number of resistors. Now in this circuit we have only two resistors R1 and R2. So 1 over R1 plus 1 over R2 is equal to 1 over R equivalent. And thus we obtain that I is equal to V over R equivalent. Now writing the ratio of the current division rule, we can write the value of the current I1 passing through R1, one of the resistors connected in parallel, over the main current I is equal to V over R1, the value of I1, over V over R equivalent, the value of the main current I. Now to calculate this, we multiply V by R equivalent and we divide it by R1 multiplied by V, and thus we obtain the ratio I1 over I is equal to R equivalent over R1, and this is simply the current division rule. In general, we can write I over I, the main current, is equal to R equivalent over Ri. So for resistor R2, I is equal to 2. So we will write I2 over I is equal to R equivalent over R2.